Yes, now we can see the slides. Yes.
Okay. Thank you, CBIP, for giving me opportunity for this presentation on agri-PV. We did this project as a pilot project on behalf of Government of Gujarat. So GIPCL was awarded two projects of 1 megawatt each to be implemented in, you can say, Central Gujarat and one in South Gujarat. With me, Mr. Mistry is also there. Actually, I am logged in with his credential only because I am for some official urgent work at our Surat plant. So I am able to join with his credential. So along with me, Mr. Mistry is also there, and he was fully involved in implementing these wonderful projects for Government of Gujarat. So just I will take you through the whole journey which we had with this very good project, which had a very impact on the overall policy decision making of the Gujarat government. Just this is a brief how the background of this agriculture solar has come. So Paris climate change was the trigger of this 100 gigawatt announcement by PM and things like that. Everybody knows, and still our energy mix is quite heavy with thermal, as everybody knows. We need to reduce that drastically, and looking to the global warming, that everybody is now on their foot to see that it happens as early as possible. Otherwise, we can have a devastating effect on not only on maybe coming generation, maybe a lot of other systems of the world. So again, agriculture scenario in India is almost 54.6% population is engaged in agriculture, and they contribute around 17.4% of country's GDP. So that's the actually very, you can say, skewed, you can say, contribution to the GDP compared to what population are engaged in agriculture. So that's a very important thing, that farmers must have should have their more income, so they can do a meaningful, or you can say larger contribution to the this GDP of the government of India and India as a whole. And area under cultivation in India is approximately 328 million hectares. Out of that, Gujarat is almost 110 lakh hectares. That's what we got from various sources. Now, what are the challenges basically? See, as in previous PPTs also, a lot of people have, speakers have already highlighted, issue of land acquisition for solar parks. That's the biggest challenge. Huge investment in land and power evacuation system. Actually, see, myself is working for a large solar projects and solar parks. So we know there's a huge challenge in creating an infrastructure for ST power system. And that not only involves a lot of cost, but time, and you can say that's a sunk cost which is going into that total system of the renewable energy. And one peculiar thing about renewable is that utilization of that ST system is very low. So only 25% CUF and 75% time that ST infrastructure is remaining idle. So that cost loading of that ST evacuation system is so high that is loaded 4 times to the renewable. So that's why it's more important that we find a solution that is distributed solar. So at least that cost is eliminated to the great extent. Another thing, inadequate rainfall, crop failures, problem due to drought and things like that. Tackling diverse challenges by government, agriculture, electrification. There's a major challenges throughout the India. Gujarat is better off because of a lot of effort being done in past several years. But if we talk of whole of India, there are a lot of potential to improve that our agriculture electrification area. Financial health of DISCOM, we know that it's a major challenge in sustainable growth of the renewable power. And then job creation, though in small number, but these distributed power definitely create a lot of small job opportunity in the directly rural areas. What was the objective and vision? Make farmer the primary stakeholder in energy generation. Decentralized generation of power to reduce the losses, as I already mentioned. Power generation near the load center. Here what happens, no? Wherever we generate the power, it is consumed within maybe 3, 5, 4 kilometers. The losses are reduced drastically. Not only capital cost, but your energy loss, transmission loss, or wheeling charge, everything is reduced to great extent. So these are very, you can say, a welcome, you can say, step that distributed solar is given priority by government of almost all states and also central government. Helping achieving RPO obligation of DISCOMs, that is one of the again major concern that can be addressed through this distributed solar. Here RPO is generally taken by the DISCOM, so small farmers or maybe developer doesn't have any mechanism to take that RPO, so that's also indirect benefit. Water conservation and recycle through reuse, that obviously it's part of that distributed solar agro PV. I will not go into detail of this slide because I think these are covered into almost covered in earlier presentation by my colleague speakers. Just Gujarat and particularly Western India is endowed with a lot of solar energy. So it's an ideal case of putting a good, you can say, solar systems, maybe ground mount or maybe roof mount, whatever it may be, but almost 4 to 7 kilowatt hour per square meter per day of solar radiation is available. Complete of Rajasthan, max part of Gujarat, Maharashtra, Telangana, Andhra, things like that. So Gujarat is lucky to have that resource in abundance. What is distributed solar with sun? Sun makes farm more efficient. That's our punchline. Dual use of land use generating solar power land with agriculture on the same land, providing opportunities to increase farm income as well as contribute to nation's energy need. Solar is new cash crop in the farming sector. We can term this solar as a new cash crop basically. So it should be viewed in that sense that farmer has another crop in this field. That's electricity generation. That's all. If we take that approach, I think farmer can also be very much interested and we can easily convince that this is great. It will greatly increase their income if they are agreeing, because what we saw during our interaction with farmers, there are a lot of you can say queries regarding their approach for how it will work, whether it will generate, will have losses, things like that. I'll just cover in my next slide, but there are a lot of apprehension in farmers regarding putting the solar. But once we say that it's a cash crop, then I think a lot of problems can be solved. Yeah, see what are the basic initiatives that we took for implementation this 2 into 1 megawatt pilot project for government of Gujarat. There was a government resolution in 2015 to demonstrate agri solar, because Gujarat has been pioneer for showcasing a lot of solar innovation in past also. So government of Gujarat were kind enough to give 2 projects to GIPCL, Gujarat Industries Power Company, with some financial assistance. So at least we can sell the power to DISCOM at very competitive rate, because in those days the project cost was around 6 crores per megawatt. So and a lot of development was done. So most of the finances was done by government of Gujarat. So at least we could give the power at very marginal rate to the government. Here main thing is that as a Gujarat Industries Power Company, we had a power background. So we did all the design, engineering, procurement, installation, commissioning from our own team. We didn't hire any EPC contractor for this whole project. Everything was done in-house. That was the beauty of the thing, and we could you can say take suggestions of all the farmers. Agriculture university was involved in their you can say suggestion how we can space the panels and structure and things like that. So it was a total, you can say, all in all, you can say feedback was taken from all the stakeholders. So the project is successful. Again, last you can say all MOU was signed with agriculture institutes, Anand Agriculture and Navsari Agriculture for experiment of various crops in solar project. I am happy to say that even after say 4 years of implementation, still we are doing a lot of crop experimentation below the panels and between the panels to see what crops we are able to grow and what are the yield and things like that. So we have a whole lot of you can say database available for most of the crops which are grown in central and south Gujarat. These are the processes. Just I will share quickly. First, we identified the land where we can put the 1 megawatt project. So luckily, being a government you can say supported entity, we were able to quickly locate 2 hectares of land in central and south Gujarat. So that was not big challenge. And we put 1 megawatt in Vastan near our Surat lignite plant and 1 megawatt in Amrod, village Amrod, that is in Anand district near you can say Anand University only. So the main purpose was to have a different climatic and geographical condition to see that whether which type of crops can we go and what are the yield levels and things like that. We formed teams for implementations, agriculture scientists, local farmers and engineers from GIPCL. Farmers meet, you can see the photographs where at every level we had a continuous feedback and you can say involvement of farmers in from concept to commissioning, that what are their apprehension, what are the need, whether they will be comfortable with this height of the structure and tilting of the structure, spaces between the rows and things like that. You can see that blue color template which we have made. No, see that was prototype with MS sheet we had made in our thermal plant. That how the shadow will move from you can say morning 8 o'clock to 5 o'clock if we keep some gaps between the panels. The idea was that there should be some sunshine going down the panel so that at least photosynthesis effect is available to the crops which are grown exactly below the panel. So we had idea of creating 2-3 variants of this you can say spacing where we have made actual our plant. So before that we found that at least there is 1 and 1.5 hour you can say radiation or direct sunlight is available between the panel also. So that is available to the crop below the panel. So that much photosynthesis is always available. So what agriculture university said that even a 1 hour of photosynthesis is quite effective, or you can say for increasing the yield of you can say where the sunlight is required. So that was the whole purpose for the experimentation. So just I will briefly again come to my this main concept that we have kept 125 mm, 150 and third row was with no gap. So 3 variants were installed in our plant to see what are the yield level and how the crop yield is actually measured below the panels basically. We did the shadow analysis using SketchUp Pro, this software, that what should be the ideal distance between the 2 panels. So we kept 8 meters between the panels so that there is no shadow effect on the other line. Normally 6 to 7 meters is sufficient for 2 portrait design, but with the help of farmers feedback and going by a slightly safer this thing, keeping the irrigation requirement and things like that, we slightly use the higher distance between the 2 panels. So agriculture should not suffer because of optimization of the solar. That was the whole idea. To just share my this thing, we had 2 hectares for 1 megawatt. Ideally 1.7 or you can say 1.5 hectare with the higher capacity of module now it is sufficient for 1 megawatt, but here we used almost you can say 25% more land for agri solar. Here you can see that for the cropping pattern initially we had during the first year during at Amrod project. So we sowed almost all major crops which are being used by the local farmers in that region. So all these things were coordinated with the Anand Agricultural University and Navsari University so that we can get the first hand information of the crops which are being regularly used in that region. So we had a very good database of all this crop, and now it's almost 4 years. So we had a you can say 200-page report which have complete detail of each and every crop and what is the yield in 25 mm, 150 mm and 250 mm gap. So we are measuring this crop with the control area. So we are measuring what is the compared output in the control area where there is open space and there is no panels are mounted. So whatever we put below the panels or between the panels, we also same crop is grown outside the panel area also. That is the control area. So we are able to compare that yield in a more scientific way. This is one of the special feature of evacuation where we directly connected this power evacuation system to the 11 kV rural feeder. We did not spend any you can say not a single amount on making the transmission and distribution. So directly 11 kV feeder, rural feeder was going nearby the plant. So directly we taken the connection, and with the all control protection system devised by our team. So all safety features are inbuilt in the plant system, so that it effectively shut down whenever there is a grid failure, and automatically starts whenever there is a grid is available. Here the problem is in rural feeder. No, even in Gujarat there is almost you can say 7 to 8 trippings in a day wherever there is, because these are very large length feeders, maybe 15-20 kilometers. So whenever there is some bird fall, or maybe some trees is falling, maybe some or other any weather related issue, 11 kV feeders are getting tripped, or maybe due to power curtailment also many times these feeders are tripped by the discoms. So all these jerks are being taken by the solar plant with no you can say detrimental effect whatsoever since last 3-4 years. So that's our experience on 11 kV rural feeder this thing. As I earlier said, no, minimum transmission distribution loss is almost 1% compared to average loss of 8 to 10%. So here we are almost saving, you can say 88-90 paise per unit in transmission cost. Otherwise, that cost is loaded to the tariff, and ultimately it's a cost to public. So that's the very important aspect. We can convince, you can say MNRE or maybe the other bodies that here indirectly we are saving a lot of transmission losses as well as you can say capital cost. Water conservation, I think this is now everybody is aware that we had developed drip irrigation system, giant drip irrigation system along the solar plant, and same with the same drip irrigation system we had taken tappings for cleaning also, and local manpower is being used to clean the panels, and same water is being used for just dripping to the farm. So not a single drop of water is getting wasted, you can say. So 100% water is being now again used for the agriculture. Again, use of available resources. We developed a SCADA for plant monitoring. We use whatever available, our spare cable trays, control cables, poles, etc. were available. So we try to, you can say, optimize the cost with available resources of our old plant. Employment opportunities, you can say few diploma holders are being employed as a control room operation, then angle changing, PV module washing, because here we have kept angle changing also. So there are 3-4 times we are in the year we are changing the angle. Security persons we are keeping round the clock. So 1 or 2 people are there for security also. So indirectly we are creating some help to them also. These are, you can say, direct outcome of this project. Land acquisition not required, reduction in capital cost, irrigation solar pump during daytime. Here, no, in Gujarat, sir, basically agriculture power was supplied in during night time, and during night time, no, there was a large complaint, you can say, or representation for farmers that during night time there is a snake bite and maybe other issues are there going into the farm. So generally they prefer the power should be available during the daytime also. So with the solar distributed, that is possible if we allow that use to power during daytime. So that one of the biggest problem of farmers can be addressed also. So they get power in daytime. All other are now known because is well, I think, discussed in previous PPTs also. These are some of our outcome basically. We are able to supply almost 1,000 to 1,200 rural houses, reduction of CO2 footprint. CUF, these are 1-to-1 DC. We have installed exactly 1 megawatt of DC. In those days, DC addition was not allowed. Now up to 40% DC addition is allowed in mega plant as per inverter capacity. But in those days, only you can say 1 megawatt DC equal to 1 megawatt AC. So that was still we are getting almost 17-18% of CUF after 3 to 4 years of operation. These are some of the agriculture our data which just are shared in the screen. Technology is okay. Challenge is already discussed. Gujarat, no, in Gujarat, cost to serve electricity to agriculture is over 6 rupees per unit. Now you can say it's a huge cost which is cross subsidized, and you can say these are loaded to the industrial or the other commercial you can say unit. So indirectly we are making the industry non-economical, you can say indirectly tariff heavy. So I think with the intervention of these type of solutions, we can also indirectly help industries at a large, so that there at least power cost is also reduced actually. So cross subsidy is a major issue maybe in all the states. I think with this intervention, that can be also addressed to the great extent. Here the Gujarat's under recovery for power to agriculture is almost 9,400 crores per year. So that is also huge subsidy which we are giving to the agriculture. These money can be diverted indirectly by maybe some CFA or maybe some tariff and things like that. So indirectly, once the payback period is achieved, then government is able to, I think, recover and they will be better off by reducing the overall tariff in the system for cash customer. Limitation of fossil and nuclear power, we know that there is huge risk with nuclear as well as fossil fuel. Nobody talks of fossil fuel these days, so we have no option but to go for renewable in a very great manner, and with a lot of urgency. Otherwise, we will be just losing time before I think weather god can create havoc. These are some few pictures of our plant, aerial pictures. You can see there is a gap between the panels of variant 125 mm, 25 mm and 150 mm. So crops are shown below the panels very clearly visible. These are again bird's eye view of our 1 megawatt plant in Amroad. These are closer picture of our plant where full-fledged agriculture has taken place. Thank you, sir.